So what I have set up here is a way of collecting gas as a product of a chemical reaction. Many chemical reactions produce various gases, and this is a setup for collecting the gas. So what will happen is that I'll put the acid in this flask of hydrochloric acid. This is 0.5 molar hydrochloric acid, low concentration, but it will do. And then what I'll do is once I add the magnesium, I'll put this stopper on the flask. The other end of the stopper has a tube connected to it, and the other end of the tube runs up into this glass jar. Now right now the glass jar is filled with water, and I've inverted the glass jar into this pool of water. We call this collecting gas over water. This is a technique developed several hundred years ago by early chemists. And what will happen is, as the magnesium reacts in the flask, the hydrogen gas will be produced, and it will bubble through this tube and up into the glass jar. The glass jar will be filled with hydrogen gas at the end. Produced in the reaction. So I'm going to measure this, and I'm going to measure the approximate height of the bubbles in centimeters. Let me get down here at eye level, and it looks like we have about, let's see, about 7.4 centimeters. So the bubble height is 7.40 centimeters. There you go. So we'll use that in just a moment to calculate the volume of the bubbles. And there it is.
Hey everybody. So hey, the final piece here is calculating what's called percent yield. Okay? When you do stoichiometry to make a prediction and then do the reaction, you can then calculate percent yield. Okay? Simply it's what percentage of the prediction that you actually get when you do the reaction. Okay? And what often happens is that, for numerous reasons, microscopic amounts of product may be lost, maybe as a gas or as a residue on a surface or whatever. So you may not get 100% yield, but you may get close to it. Okay? So percent yield, what percentage of your prediction did you actually get? Okay? So it's simple to calculate. It's a percentage. It's the actual yield, meaning what you actually got during the reaction, divided by what's known as the theoretical yield. This is your prediction from your stoichiometry problem. Okay? So the actual divided by the theoretical times 100 gives you the percent yield. And it is simply a percentage. Okay? What percent of the prediction did you actually get? Okay? So as a quick example, let's say that you're doing a reaction and you predict that you're going to get 38.72 grams of product, okay? And then you do the reaction and you actually get 38.44 grams of product. Okay, so this is what you predicted, and this is what you actually got when you did the reaction. Okay, so the way you would set that up, the actual yield divided by the theoretical yield or the prediction. There's a 3 there, I promise you. So 38.44 divided by 38.72 times 100. And that gives you the percent yield. Okay? So if we calculate here, I'll put that in parentheses, 38.44 divided by 38.72, you can see it there, times 100, and there it is. I'll round that to 2 decimal, 4 sig figs, like our measurements here, and that's what you'd want to do, round to that same number of sig figs, 99.28%, which is pretty good. So for this reaction, when the person did the reaction, they got 99.28% of what they predicted. Okay? In a nutshell, that's percent yield. Okay? All right.